Good morning, everyone, and Jule, as we greet in Ladakh, where I came from this morning. Just an hour ago I landed, and I'm happy to be in the warmth of Delhi and friends like you after the icy heights of Ladakh. And I'm very happy to be amidst you all and Living Sciences, celebrating science. And I very much associate myself to the quest of science. And it was this quest that had led me to opt for engineering, mechanical engineering, although my life has been not so much only in science, but more in more social actions to improve lives of people in whatever ways one could, from education to awareness and other activities, including activism of different kinds. But it all began with my interest in science and in high school, which is when I was wondering what I should study. Like in our country, most young people in their 10th and 11th grade are very clear that they want to do engineering or medicine, some administration and so on. I wasn't very sure what I should do and why, until in, I think, 11th grade, while studying this chapter on optics or light, I developed a great interest in lenses and mirrors that could do amazing things with light, and I could imagine how it could be applied in a cold place like Ladakh, where you could redirect sunlight to do many interesting things in the cold climate. And that's when I started asking around where I would get to study more of these things. And after a lot of people and their advisors, an uncle of mine who was an engineer said, you get to study more and do more such things if you choose mechanical engineering. And that's how I chose engineering. I'll cut the story short. And while I was doing my engineering, I had to support my own education. Somehow I was on my own to support my education. And that led me to do something that would earn me the expense that it costs to do, not the cheapest that engineering was in those days, and even now, I assume. And to do that, I thought of teaching young people, 10th grade people, what I loved, which was science, maths, and so on. And that exposed me to the problems in the education system, because anyway, schools are very painful for everybody, but in Ladakh, up in the mountains, in a very different world, with a very different lifestyle, it was, as I say, doubly painful. Not only the students were ethnically, linguistically, climatically a minority that didn't quite understand things in textbooks that were designed for New Delhi maybe, which were just transplanted to the mountains of Ladakh. They didn't get to make any use of these in real life either. And later I learned that these things didn't really make much sense to New Delhi also. You know, it was Ladakh getting a copy of its books from a city like Srinagar, the state capital. And if you look at that, they get a copy of their books or curriculum and education system from New Delhi. And if you look further, New Delhi gets its copy from London. So the copy of a copy of a copy, when it reaches the high altitudes of Ladakh, it makes no sense. It's hardly legible. No wonder that 95% of the students used to fail in those days because of this irrelevant system. And later I learned that it actually didn't make much sense in London either. Yeah? So, much less chances that it would make sense up there. So that's what moved me. And I went through a realization that life shouldn't be only about what I need, but also and more so about what needs me. So that's when I thought I could, for the time being, leave my lenses and mirrors on the back burner and try and solve this educational disaster that Ladakh particularly was going through, where, as I said, 95% every year, repeatedly, of the students would fail in their 10th grade exams. And each year they would be blamed for being bad. Nobody would question the system. They would just brand the products bad or maybe somewhat retarded. And some teachers who would come from different parts of Jammu or Kashmir, who didn't understand the language problems, the context and so on that children had problems with, would even devise pseudo-scientific explanations. Talking of science, sometimes we try to explain things the way we want to. So they would say, these kids in Ladakh will never do well in education. They don't have enough oxygen in the air. So you can imagine what could children do about oxygen in the air? They can't fabricate, so they might as well give up. We can't, because we can't. And that was the situation. So naturally, it's about the impact and the outcome that our lives should be about, rather than the ritual of doing something for the sake of something. So I chose at that time to work for education, because that was more calling, that was a louder cry than my passion with lenses and mirrors. So I thought, what is calling me is more this, and therefore I started with the system of education. After doing a lot with the government in government schools, as you saw in the film, we then soon started working with those who were still failing when the results started improving. Yeah, the results went from 5% failure to slowly 18%, 26% success, 5% success, to 26, 55, and finally some 75% or so, which was good, but not that great. Which was good, by the way, to prove that it was not oxygen in the air. The science of why students didn't do well, but it was really not good for somebody who had spent a precious quarter of their life in a system that was supposed to educate them, and then they stamped them a failure. So 25% failure was still a very bad number. Even 1% is a very serious figure if it involves you or your child, you would agree. Otherwise, it's statistics, figures, and it's improving. So we thought of working with those who were still failing, which a little bit you saw about. And there we tried to celebrate science in different ways and use the science and maths they study in high school to solve problems of people, rather than just memorize them to get marks for yourselves, and not much later either. So things like these passive solar heated buildings, which in mid-90s were a rare thing. This campus, this school that you saw, was built with students who were failing in the system to create a school that would be very special in that it gave highest priority in admission to those who had failed, and would do things differently with them. If they didn't learn the way they were taught, they could perhaps be taught in the ways they learn. And it's natural for young ones of any species, not only human, but any species, that they learn from doing things, that they learn experientially, physically, mentally involved in things and creating, applying, failing and learning, rather than being trapped in a classroom and lectured 8 hours a day. It's more natural for us to learn outdoors in application rather than in memorization. This is how we humans have learned for millennia. As hunter-gatherers, we were always outdoors learning, along with our grown-ups, in challenging and often life-risking ways. As settled farmers, we again learned in those ways, in the thick of action. In fact, I believe that we have evolved. Evolution has designed our young ones to be out in action and learn, and that's why human young ones or teenagers are packed with the gift of energy to deal with all that action. And that's a natural part of it, is what I believe. Suddenly, some 300 years ago, we switch over our lives and outsource everything to fossil fuels from millions of years ago, and everything becomes a touch of a button. And add to that, over-parenting from parents who bring everything on a platter, from shoes to be laced to homework to be done, and the kid has nothing to use their energy for, but nature, through evolution, in my opinion, has gifted that bundle of energy with the young one for this phase of learning. And that energy has to come out somehow. And it comes out in our civilization today in ugly forms called teenager rage, rebellion, problems, and so on. We hardly knew of such things in remote Ladakhi villages where young people are always side by side with grown-ups to face the challenges of life. We don't know of anything such as teenager problems. They are actually respected in society for contributing in very meaningful ways and not seen as a problem. So therefore, we thought that these students who were not doing well in those schools were actually not unusual. Unusual are those who are doing very well, actually, for what humans have done for millions of years. It's very unusual if somebody is doing great in just listening and writing and memorizing. I'm more surprised that 5% pass in this kind of system. So there's nothing wrong with such people who need a different way of learning through the fingers rather than just ears and eyes. So therefore, this school, where we celebrated, science and other things by applying. So these buildings, as I was referring to, the zero energy, passive solar campus that we created by 1996, when these terms were actually not even invented, zero energy or off-grid and so on, were a part of our quest to apply what would appear in your high school science as the chapter on heat, with all its conduction, convection, and radiation, which you generally memorize and write down and get some marks and be done with it. Here we wanted to try and see how conduction would absorb the sun's heat and then transfer it from the outside of the wall to inside of the wall where the occupants live, molecule by molecule, and bringing the peak heat of the day at midnight when it is towards the coldest times. Similarly, convection, that would work to bring the heat from the greenhouse that you saw to the building by convecting the hot air rising and moving into the building, becoming cool, while delivering its heat to the cold walls, warming them up and itself cooling down and becoming denser and pushed into the greenhouse to be heated again and moved on, like winds blow on the earth. Seeing winds generated in your own building could make convection unforgettable. Similarly, radiation from the walls, keeping you warm when the sun is long gone into the minus 20 nights of Ladakh, and the room remains at plus 15 or plus 18. That's a beautiful way of applying what you have and making your life comfortable and then sharing it with people to solve their problems. So that's when things come alive, and building those buildings yourselves, the students, hand making the buildings brick by brick. That's where the energy, the teenage energy goes into learning and into facing all the challenges. And then your energy is spent in becoming partners of the school rather than problems to be solved. Similarly, passive solar, when we applied this greenhouse technology that we developed in our school to animal sheds, for example, cow sheds, we were amazed. It was out of a kindness to all beings. Not only humans should live in passive solar buildings, why not the cows? And the students built a cow shed that was solar heated, that would stay at plus 12 when it is minus 15, when other cow sheds in the area would be minus 5 inside. And we learned that the cows treble their milk productivity in winter. Again, an encounter with science that we didn't know, to find out that suddenly these cows, who we do this favor or generosity, reciprocate by giving 3 times more milk. And then we go back to the science, why, and learn, okay, in that chapter it said that certain animals are warm-blooded, others are cold-blooded, and warm-blooded animals have to maintain their body temperature spot on certain temperature, like 37 in our case, or in the case of cows. A degree down or degree up would mean death, no matter what the external temperature is. So even if it is minus 5 in the cow shed, the poor cow has to maintain her body at 37 degrees, or else it will die. Where will it get? Will she get the energy to maintain such a big difference in temperature with the environment? From the food, the cow feed, it would go only to keep her huge 300 kg body warm at 37 degrees. Now, when we did a passive solar cow shed, it was a much cheaper way of using the sun to make her environment come closer to her constant body temperature. So at 12 to 15 degrees, she has to use much less of her food to make heat to keep her body warm. And therefore, the food will become more milk. And therefore, we could explain, now that's why she gives much more milk. The generosity has a scientific reason, the reciprocation. So, engaging children to see alive these basic sciences and to see that it helps human populations to have such assets as milk and so on, solving a lot of problems. Now, applying very simple science to do that. Same with ice stupas that you saw. Together with my students, we started seeing how we can solve the water issues that we are facing. We have always faced in a desert that we are, high altitude desert. But add to that the climate change issue, which makes things even more erratic. So glaciers are becoming smaller and they have lesser to melt, and early in spring it's even not time for them to melt, so farmers would have even less water in springtime when they all need water. But come July or August, when it gets all hot and hotter now year after year, the glaciers melt fast and it causes even floods, excess flow when you don't need. When plants have had enough, then is when you get big flows, and these flows continue into the winter. Autumn and even winter there is a flow under the ice. You would wonder sometimes whether in winter the whole thing freezes. No, it doesn't. Water always makes a shell of ice and then flows under that shell, getting warmth from the earth and the shell outside is like a greenhouse made of glass, not glass in this case, but ice. So it keeps flowing. But nobody needs that water in winter. So why not use that wasting water and freeze it till spring, late spring, when everybody needs water and there are conflicts? But it is easier said than done. How do you keep ice from winter till May or June? You don't see any ice on the ground. It's all gone by March. So the challenge was, how can we do that at lower altitudes? At very high altitudes you can, and it's been done. But very high altitudes are so far away that people can't reach easily. How could you do that at village level? And that's where again what came to our help was science, high school science at that. My belief is that 80% of world's problems would be solved with not more than high school science. You rarely need a PhD, For the last 20% maybe. So many things could be solved with so much simpler things, but we really don't value the gems that we are handed. We think of them as a means to pass the exams. That's sadly the situation it has become. We'll come to that. I've seen a lot of, I've seen that we have some question answers later also. We can touch them later. But it is in its application that things are, worth what they are. And therefore, if you really apply what you have in high school science and maths, you can solve a lot of problems. So this problem of whether winter ice can be kept till spring or late spring was a question. And when we said we are going to attempt it, people laughed and said, "What? You don't see any ice after March. How are you going to keep it till May or June?" Good question, but we didn't want to just be shut up by that. We kept our eyes and ears open to see if it's really true. And then we observed, for example, under a bridge outside our school, that there was a big chunk of ice in mid-May, which meant that it's not spring that really melts the ice, because spring is also happening under the bridge. Bridge is no different. It has the same warm air, but the ice still remains, which means that it is other things that melt the ice. And what is different under the bridge is, as you can imagine, compared to other places, direct sunlight, right? That's what is missing under the bridge. So it's sun that melts, not warmth of spring as much. And therefore, if you cut the sun, you can keep till May as under the bridge. And you can, if you do it at scale, you can use that water for watering things. That's what we understood. And again, easier said than done. How do you cover a huge mass of ice? No bridge possible. No material possible. We were thinking for a long time of materials, and then finally got out of that materials box to use something as unusual as high school geometry rather than umbrellas and bridges. Now, how we used high school geometry was what you all go through. In geometry you get to some chapters that say certain shapes have minimum surface area for the given volume, like spheres, hemispheres, or even cones. Why I'm talking about surface area and volume is because surface area is what the sun wants to melt ice. Volume is what the farmers want to water their plants. Each doesn't care about the other. Sun doesn't care about the volume. Farmers don't care about the surface area. And therefore, if there was a shape which encompasses maximum volume for minimal surface area, you can perhaps use that instead of a bridge or an umbrella or a covering material. And that's when we did prototyping of the concept. Again, doing and making prototypes, and if possible together with students, is the best experience that they could go through and make things unforgettable. We often blame children of forgetting their lessons, and I have a complaint. The lessons are so forgettable. Why wouldn't anybody forget something that is so forgettable? How about making them unforgettable? Unforgettable then they become when you use more senses of your body, all the organs, and your whole being in doing it. Then you have so much to hold on to that experience. And therefore, we did these prototypes where, for more practical reasons, more than a hemisphere, perfect hemisphere, etc., cones were more practical because any dripping water makes a cone in a cold country when you have dripping water. So we did what you saw, the ice stupas, so a cone of ice, pyramid of ice you could say, using the fluid property of water, thereby making it rise itself, again using a very simple high school science principle that water always maintains its level. So if you get water from a upstream point in a pipe, the intake being high up, and in mountain terrains you always have an upstream and a downstream. That's by definition, hilly terrains. So if you put a pipe upstream and bring it downstream, the water will want to go to the same level as the intake. In other words, there will be pressure to go to that level, and to that you put a fountain, then it will spray water in the air, minus 20 air in winter, making this, with this intermingling, the water to lose its heat. The heat is called latent heat, another term that bothers us in exams, right? Latent heat. And you just make it lose that latent heat of the exam time problem, and suddenly that water which goes on its own becomes solid, pyramid, without building a pyramid like the Egyptians might have done with a lot of human drudgery. You're able to just use high school science of water maintains its level and making the liquid lose its latent heat to freeze solid and make a pyramid on its own. And now the pyramid or the cone has low surface area for the volume, and therefore it shouldn't melt. And that was what our hope was, but it was a hypothesis. So therefore a prototype to test it. And happy we were when we saw that the first prototype lasted till May 18th. The ice, unlike any others, and same as the bridge. And the bigger pilot that we built lasted till July 6th, the ice. And it melted slowly to give its water in May, June, when plants need the most. So using such simple science with no moving parts, this pipe has no moving parts, just a pipe, no electricity bills, because there is nothing consuming gravity, or in the heating system, just convection, conduction, radiation. These don't cost money. These don't have active technologies. To me, the simpler technologies are, the more evolved they are. It's somebody said it's simple to be difficult, but difficult to be simple. So bringing it down to common people's understanding and application and solving their real life problems is what I think we should strive towards in using science to solve problems. Often we end up using science to create bigger problems than the problem we started to solve. And that is what I would like to caution you all. A lot happens in the name of science and technology, and unknowingly we end up being trapped into layers and layers of even bigger problems. So anytime we think of using technology, we should not lose sight of the bigger picture of solving ultimately issues and making things simpler and happier for the world. Otherwise, we might end up in a situation like we have ended up. Can you believe when somebody invented the motor cars or the elevators and escalators and industrial products of different kinds, they must have been very excited about the invention, discovery, and not thought about how damaging it could be. But 100 years later, today, thanks to these motor cars and the rest of the industry, more people are dying than any other reasons or diseases could have killed. Thanks to these cars and elevators that make our lives easy, and whoever started must have thought only of that. People are dying of diabetes, people are dying of heart diseases. We never thought that this simple thing could cause other problems we never can imagine. So, life seemed to become simple, but now people are dying more because of those than running a few steps would have killed them, or walking a few kilometers would have killed them. And the amount of pollution that is produced becomes like a weapon of mass destruction today. I like to say that our times today are very violent times in a very different way. We don't do violence in the ways our ancestors knew, with daggers and with spears and with maybe guns. No, that has gone down. That has gone down to, I was checking actually, causes of death today. Physical violence of the old conventional kind has gone down to number 26 on the list of causes of death. Number 1, 2, 3 are all environmental, lifestyle related. So these very solutions that seem so interesting have become the biggest cause of human suffering and death. 9 million people died the year before last due to pollution alone in the world, and 2.5 million died in India due to, I'm just taking one example, air pollution alone. Did we think that we would kill so many with our so-called development? This figure is bigger than tuberculosis, cancer, AIDS all put together. We're killing more people with our science that we were so excited about. We have to be very careful when we apply science. I think science is great in our study of nature and understanding the world and the nature we have come into. It's a great thing to learn, but we have to be very careful when we apply. We have to have the wisdom of knowing what to use and what not to use. To know is one part, but then to use is totally a different part. You may want to know how bank robberies happen, how murder happens, but you don't want to do it. That is what ethics is about. That is what, wisdom is about. Not doing everything that you can do. And that's the problem today with science and technology. We seem to be acting more like monkeys than wise people. It's the monkey mind that is so excited. I can do this. But everything you can do, you better perhaps not do. Right? That's the bigger learning we need to get than just the science itself, is to where the line is, what we should do and what we shouldn't do. That's where the difference between cleverness and wisdom comes. Cleverness is in knowing how to do things, like monkeys. Monkey mind can be so excited, but if you start doing everything that you can do, you might land in much, much bigger problems than what you started to solve. That's where I think the wisdom we need to acquire while we learn what our science and technology can do. That is, I think, this century's biggest challenge, to know where to do things and where not to. And generally, when I said we are living in very violent times, I was actually referring to figures that I have seen. You might agree. 3 years ago, WWF came up with a report which said that between 1972 and 2012, 52% of the world's wildlife population has been wiped away. 52% of the whole wildlife, which took how many millions of years, billions of years, is gone just in the last 40 years. And we don't even think of that as violence. We are so anthropocentric. Human alone is what we think of. If human beings have it a little easier, we can dispense with plants, animals, and so on. That's a very dangerous thing, even for the human beings, because it is all an interconnected, interdependent web which we are cutting, like the proverbial, branch that we are sitting on. That's what we need to learn where to stop and start. And I would hope, actually, more than making these animals go extinct and plants go extinct in the name of science and technology, like you hear, every 10 minutes there's a species going extinct. This should shock us. I would want to believe that in times to come, in your times, in the generations, we would go beyond what these industrial revolution scientists and engineers have believed and done, to more evolved beings who can not only think of their own comfort, and in more real ways than the ones who thought, not climbing a few steps in a building was a very clever thing, not walking a few kilometers was a very clever thing. No. More holistic view of all beings on this planet, looking at the bigger picture. I would like to believe that we would evolve in our consciousness to think of not just humans, but all animals and plants that share our planet. And I have great hope. 100 years ago or so, slaves, nobody could think, could be voting. There was no right of vote for slaves. Then it became a reality. Slaves became as good at voting as anybody else. Thinking of how we can evolve, I'm just trying to share with you that something we couldn't even believe, or those who had such colonial slaves couldn't even believe would happen, has happened. Everybody today has one vote. And later, women could be equally powered to vote was something unthinkable. Women, of course, they don't get to vote. Men, the family man, will vote. So franchise to women was unthinkable. And today we have every person, man or woman, slave or we don't even have, every person can vote to decide the policies, the future of our country or the planet. So, if that's the case, if such unthinkable things can be done, then my hope and my question is, can we think of a time when every animal can vote, every plant can vote? Maybe not with a vote or a voice, but we will consider the vote of every animal and plant, who are now voting by going extinct. They're voting by walking out of the system. Can we consider of a time when all plants and animals on this planet as equal, in their right to be happy on this planet? And that would be a time that we can usher using with wisdom all our, education and development and what we have. So with that great hope that we have seen how we evolve in our thoughts to come out of such narrow-minded thinking of, difference between human beings, can we go beyond to a planet that respects every plant and animal, is what I look forward to. Thank you very much. Thank you.